I got the Cannizzaro reaction coming straight at you. So the Cannizzaro reaction is one where you take two equivalents of an aldehyde, you react it with sodium hydroxide and water to get an alcohol and a carboxylate anion. This is a unique reaction because the aldehyde is both oxidized and reduced, and this one reduced and this one oxidized. One important requirement for this reaction is that there be no alpha hydrogen to the aldehyde. The alpha carbon is adjacent to the functional group, and the beta carbon is 2 atoms away from the functional group. Benzaldehyde will work, and that's the example we're going to be using for the mechanism. This won't work because there's an alpha hydrogen right here. This won't work because there's 2 alpha hydrogens. This will work because there's no alpha hydrogens. So now we have the mechanism of the Cannizzaro reaction. One equivalent of the aldehyde, and we're going to add one of the hydroxide to this, and that's going to go up there. And so from there we get the anion. And my outlook on life is, why have an anion when you can have a dianion? Take this down here, deprotonate that oxygen, and we have doubly charged species over here. And these oxygens are so electron donating that this hydrogen wants to leave electrons intact. So we got a hydride shift here to another equivalent of aldehyde, and that's going to go up there, and this is going to come down here and form a double bond. And this is the rate determining step. From there we have 2 negatively charged species. We have this, and we have this. And to determine which one is going to get protonated and which one is going to remain an anion, we can look at the pKa values of their conjugate acid. For benzyl alcohol, we have a pKa of 15.4, which means that its conjugate base pKb will be negative 1.4. This is a pretty strong base. We have a pKa of 4.21 for benzoic acid, and that means that its conjugate base is going to have a pKb of 9.79, which means that this is a weak base. So this one's going to remain an anion. Take a hydrogen from water, and then from there we have our final products, our salt, our benzyl alcohol. Immediately after you're done with it, you can separate it out. So this salt, as you'd expect, is water soluble, and then this alcohol is going to be soluble in ether. So you can just throw the products of your reaction in a SEP funnel, add ether, and separate it out. I'm going to show you some variations on the Cannizzaro reaction now. It was called the cross-Cannizzaro reaction. In the cross-Cannizzaro reaction, we're only going to start with 1 equivalent of aldehyde instead of 2. And that's because we're going to use formaldehyde as well, and that acts as the second aldehyde. We're going to react an aldehyde with NaOH, H2O, and an excess of formaldehyde. This is unique because it's selective for the alcohol. It's selective for reducing. So we're going to get 100% or close to that of the alcohol, and also formate ion as well. Another variation of the Cannizzaro reaction is the intramolecular Cannizzaro reaction. And here, for example, this unique molecule, we have 4 aldehydes off of the benzene rings. And so what we're going to do is we're going to react this with NaOH, like any Cannizzaro reaction, and an HCl workup to get rid of the ions. 2 of these aldehydes are going to get oxidized, and 2 are going to get reduced. Ooh. Peace.